me. It is nice to connect back with Buet. And it's nice to see that there is this excellent opportunity to, through ACM chapter, this. Thank you all for organizing this and inviting me for the talk. So let me share my screen and then start, then go into the talk. Okay, so today my talk will be, my plan is to go in between Bangla and English, so to make things more friendlier. But then many of the technical things are in English, and then I am used to explaining them in English, so I may mix things up. My apologies.
No, this is completely informal, so যেটা তোমার সুবিধা.
Okay, thank you. So so going into the talk, my research talks about how we can automate the management of networks and how data and machine learning helps in that process. So I, as Madam introduced, I finished my PhD in this June from UC Davis, and then actually this is my third week with Sonoma State. So as you can see, my slides are still from the UC Davis template. A little bit more about me. In UC Davis, I was working with Professor Vishwanath Mukherjee. He is a very big guy in computer networking, especially in optical and large-scale network resource management. And while working with him, I also engaged in research activities with other professors inside the department. So it's a very collaborative environment. I do work with professors. One of my thesis committee members is from computer security background, so I do work with him. Another one of them is from algorithms background, so he will give feedback in my research papers and such. So it has been a very nice learning experience. I was not thinking, when I started my PhD, I was not thinking that it will be this comprehensive, this excellent opportunity to learn, research, learn how to engage in cutting edge research activity and engage in education. So my PhD supervisor talks about that we are in this business of creating knowledge, that we sometimes talk about what is going on now, then we keep talking about, and then we create something new which will happen in the future. So it has been an excellent opportunity. And then in between my time in academia, in education, I had this another aspect of opportunity to learn through my industry experience. So during my PhD, what will happen is almost every summer I'll go back to AT&T labs and then work in very, very interesting projects with them. So what happened is my PhD research changed a lot because of the kind of works I was doing with AT&T Labs. So in 2016, it was like my first summer in as a PhD student, and then I went into AT&T Labs. And there I saw that they're doing lots of things with data because they collect lots of data. They have this large scale continental and global network. They were deploying cloudlets, small cloud footprints inside the network, which was new back then. So they were collecting lots of data, and they were doing lots of data-driven things. And then I come back to my PhD research lab at UC Davis, and in the lab back then, the data was not the big. We knew that, okay, there is this data and machine learning coming, but we didn't know what kind of problem we can solve with that, or why it's important for the people who actually manages the network, right? So from that perspective, going into there, working with the teams almost every summer, and bringing those problems in my mind and in my research have been very rewarding for me. So that brings us to the research focus of my work. I focus on data-driven solutions, machine learning. I had one project focusing on AI, on the bigger spectrum of AI. Hopefully, if we get time, I'll talk a little bit about that project with AT&T Labs. And then overall network automation, I bring in virtualization, how cloud-like components are coming into the network and making things better or making things complex. And then I try to do performance analysis of different methods and which one is better, which one we should go, optimization and techno-economic evolution. And we'll talk about those things later during the presentation. So before I go into my research, kind of to give you an overall idea what we are talking about. So when we learn about networks in our undergrad or in the initial stages, we learn about TCP and 7-layer stack. That is the fundamental of networking. So that is where it began in the, let's say, 80s or 90s. And then we started building these networks, like there was this university network, then the domains start getting connected, and there is this big internet. So all of these, all of the cities, all of the institutions are connected through this very large scale networks. So these are geo-distributed, continental, global network. And then the networks have many components into it. It has network boxes, which are like devices that processes those packets and such. And then there are these very big fat data pipes, like in many cases, they're like optical fiber. Okay, so all of these resources are being managed by one of the large entities who own them. So these are like billion-dollar highways of data. And then there are companies who have, so in case of USA, it will be AT&T, Verizon, they have this very large network, goes across the continental US and goes beyond and in the global network. In case of Bangladesh, it will be probably Telenor and other telecom ISP in the global scale, right? And then this was in the early stage of the internet, I would say 90s, and then before Google, Facebook, Microsoft came in. And now we see that as a communication company, they're not behind. They're not like, okay, I am a software company and the communication is AT&T's headache. So Google has their own footprint, global footprint, including mini data centers, large data centers, and then large backbone networks. We talk about Google B2, B4 networks, and their global scale, large scale, this kind of network, complex network. And they have many resources around that. They also have optical fibers deployed. Facebook recently deployed these petabits of optical fiber across Atlantic. So they are also investing in this large infrastructure, fibers, devices, which are very costly. And then the problem is, how can you make them efficient? This is a billion dollar investment that you made, and if you can improve the performance of this thing, capacity of this thing 10% or 5% or 1%, that's millions of dollars saving per year. So that is where my research comes in. Then we are trying to look into where we can improve, right? There is this very nice and robustly deployed network there, then what we can improve from here. So to do that, we look into the network and see that what are the components there are. The first thing we have, and we often learn about, are the network boxes. We talk about router, we talk about firewall, then there's this optical boxes that those are there. And then there is this cables which are connected to those boxes, and they go from one place to another and gets connected with other boxes, right? In often cases, in the large scale backbone network, so probably in our offices and homes, we see a lot of Ethernets, but in the backbone, it is mostly fiber optic. And as I mentioned, that is a big area where the backbone network and large scale network management comes in. And some of the existing issue with that kind of scenario, that kind of setup, is that most of the resource management is manual today. So if you want to deploy a new service or resource, or you want to fix some failure or something bad happened, so there will be a network administrator or network manager, admin, human admin, who will go into and deploy that new service, fix that firewall that is not working. So that is a place somewhere we can help the network administrators to automate things, right? Then the second point is how collected data can help. So traditionally, before Google came in and Facebook came in and they started collecting data, network and network owners like AT&T were collecting lots of data from these boxes. So these Cisco boxes reports statistical data for a long time, for many years, like how many packets came in, how many packets get dropped, and something like that. But nothing was being done about those data and using those data until recently. So that is where we have some scope to improve things. Resource inefficiency. In the networking world, efficiency is a big problem. How big of a problem? Let's say the network capacity usage in terms of, let's say I have 100 capacity of the network. The best we can do today is around 40% of the network is being used. Rest of the 60%, it's empty, it's not being used. And that base case scenario is from Google, and rest of the networks are not that efficient. So all these billion-dollar resources are not being efficiently used, and there is a lot we can do about it. Costly, that is another point, that it's costly for the network operators, people who owns the network, and it's also costly for us. So if the network operation cost becomes cheaper, it becomes cheaper for the users as well. So this is another area where we can help as a researcher and then bring innovative solutions as well. So from here, my research goes into the overall umbrella of the research goes into network automation, that we can automate things that will make the management easier, that will bring the costs down, that will bring the efficiency up. So that is the direction my research is going, the overall future direction of this area of network is going. So the idea is that as the term suggests that network automation is the process of automating things. It can be automating configuration, it can be automating management, testing, deployment for the physical and virtual devices within a network. And the benefits are many. The cost will come lower, you will have bigger insight and control about your network, more agility in the business model, and we'll talk about that point later more. And then strategic resource placement and such. And some of my research actually does resource placement, dynamic resource placement from a network automation perspective. And there is this big monetary, in terms of money, it is very motivating for the new companies and for the network operators to go in this direction. So among again, this is a very big umbrella, that network automation. A lot of things are happening. Some of the research is going into, let's say, recently with a conversation in Berkeley Lab, they did a project in 2016, which was like voice command to set up network devices. So the network administrator will give voice command to this interface, and that will get translated into, let's say, Cisco router commands. So that is a direction of automation as well. But my research mostly focuses on these three pillars. So we will talk about virtualization in next slides. We'll talk about machine learning, AI, the bigger umbrella, and data-driven solutions, and cost efficiency. So let's go into virtualization. So virtualization, we are pretty much, I'm confident that all of you are familiar with. So it comes from the cloud environment, cloud idea that we try to run everything on virtual nodes, virtual compute nodes, virtual network functions. That is where it comes into the network, that today we can run routers, firewalls, everything that were in these hardware boxes, they can be brought into virtual machines and we can run it there. Network controllers can be virtualized, and benefits are many. As in the cloud, we have seen that the hardware gets cheaper, it's easy to upgrade. So imagine today, if you want to upgrade the network boxes, network firewalls, you have to physically remove the old box and put in the new box, and then it has to be done manually. But if it was a VM, you could just run a new VM with the new firewall instance and then shut down the old VM. That is it. So it is very easy to upgrade. It is very easy to deploy new service, flexible management. So then from a research perspective, what this brings into our plate is that how do we understand the characteristics of these new things? So in the cloud, it is pretty much established and we know what is happening there. But inside the networks, there are many characteristics of, let's say, virtualized firewalls that are not studied yet and that are not modeled yet. So we try to bring, in my research, I try to bring those concepts and understand what's the impact of what happens your VM is twice the size of the current size, right? Does that impact your cost? Does that impact your network throughput and such? And then how can we model that kind of characteristics into our research is one aspect of my research. Then from a solutions point of view, I look into data-driven solutions. Sometimes we need learning, forecasting, recommendation method. So we are trying to learn from the data that we have. The solution methods can be many things: machine learning algorithms, reinforcement learning, deep learning, and etc., etc. So that area of expansion is sky's the limit. So we have in my opinion, we have just barely started scratching the surface. So there is a lot that can be done in terms of forecasting and recommendation using all these advanced techniques. Then how do I know which methods are more useful for network automation, right? How do I quantify that, hey, out of these 10 methods, this one is the best? Or there is this study which is using machine learning, but I think reinforcement learning can be a better solution. And here is what I have found. So that is the area of research which is expanding heavily in the network resource management area. And some of my research looks into that direction. In some cases, you don't really need to do forecasting. You just look into the data and make smarter decision. So without the data, you are using some optimization method, but you look into the data and that helps you. So in that case, that's the second point I have, that data-driven algorithms. In such scenarios, you don't really need to do forecasting for many reasons. In the third case, it can be that you have this data and you want to understand what's going on. So you are not doing forecasting, you are not doing automation, you are doing analytics and visualization. You are trying to explore what's going on, how the users are behaving, how the devices are behaving and such. And that is another important direction. And we see many studies especially from the network operators who actually have access to lots of data. So the third pillar of my research talks about cost efficiency. So cost is a very good motivation for automation of network management. In terms of the cost, I look into operational cost, different aspects of it. So what kind of cost you will encounter if you are operating a large scale network. It will be electricity cost, it can be heating, ventilation, air conditioning cost, which in our mind it's not there, but for the operators it's a big headache, especially when you are bringing in all these servers and compute components inside your network. You need data center kind of mini data center kind of environment where you have HVAC, employee salary, maintenance, upgradation cost. Then in terms of leasing, leasing is a big thing for the network operator, because let's say there is AT&T in USA and all the other companies who don't have this large scale network, let's say Bank of America or Walmart, they will go to AT&T and they will lease the network capacity. So they will be like, hey, I have this 4,000 offices all across the country. I need 10 GB connectivity among them. I have tons of devices which needs connectivity. So how much it will cost? That's the leasing cost. And from a tenant like Bank of America, that cost is in terms of millions. So there is cost of network bandwidth. These days there is cost of these compute instances that they can rent out of the network operator, cost of software, storage, and it goes on. And if we can help with that, that motivates the network management and automation. So how can we bring in all these different types of costs, and how can we model them and then tie them back to the original solution that we are proposing and virtualization technology? So everything comes together, and then there is this cleaner motivation to go for this management, new automation and management process. So diving into more into my research, I don't want to spend too much time with this, but I kind of wanted to show you that the thing that I was talking about, that there is this parallel back and forth between UC Davis and AT&T Labs that my research have been going on. I will start with my UC Davis research work, and then hopefully we can spend some time with one or two of the projects with AT&T Labs. So in terms of my this all four are essentially my four contributions towards my PhD. We won't be we won't get the opportunity to look into all of them thoroughly. So my plan is to spend some time, some concrete amount of time with the first one, and then kind of lightly introduce you to the ideas of the rest of the research works. So, so let's start with the first one and take it from there. So in this work, we are talking about virtualized network resource management using machine learning. And let's kind of start slow on the idea. So the key concept goes into the idea of auto scaling, which comes from cloud, as you can as you can see in the right side of your screen, that as the number of users are going higher, we are introducing more of these virtual boxes. And then when the users are reducing, you have less load, we are removing some of the virtual instances. So this idea that increasing the capacity when you have high load and then decreasing the capacity when you have low load comes from cloud computing area. And if you buy a subscription from, let's say, Amazon EC2, they provide you this service automatically. But in the networking world, traditionally you cannot do that kind of auto scaling. So let's say in my previous example that Bank of America wants 10 GB connectivity for their 2 offices to get connected. If at night they're using only 1 GB of bandwidth, but they're paying for the whole 10 GB for the whole lease period over the year. But that is not a very scalable solution. And then traditionally, we could not do that kind of auto scaling in the network. But with the virtualization, as we can see on the left in the screen, that with the virtualization, we see that more and more of these network boxes like firewall or network address translator boxes, which are like these big boxes, they're moving to virtual machines. So they're being transformed into virtual machines, virtual instances, which could be running anywhere in the cloud, right? And then once we have these VMs, this idea of auto scaling can be implemented inside the networks, because there are now these virtual components which can be easily turned on, turned off, and deployed when the load is going up. So this move towards virtualization kind of encouraged me to explore this auto scaling domain inside the network. So today, as I mentioned, network resources are not auto scaled. So AT&T will deploy this 10G connectivity all across the country for your company, and you will pay for 10G no matter how much you use. That's that. And it's bad for the tenant, it's bad for the operator as well, because there can be these new tenants that you could support over your network, but now you cannot do it because you're not doing auto scaling. So then in the cloud, we see auto scaling. In many cases, I would say most cases, they use threshold-based reactive approaches. One big reason is the cloud demand is different than the network, what we see in the network traffic demand and network traffic workload. And then our proposal was, does the forecasting of the workload help, knowing the workload ahead of the time, help in this kind of auto scaling decision? So overall, the problem statement, that the challenge we are dealing, can be kind of summarized in this figure, that uh, we have this network status data. It can be network measurement data, it can be your device status data, which comes into your system, and then we will have a machine learning based prediction model, which kind of tries to figure out the future, right? That, okay, I'll have 10 GB of traffic for next 10 minutes or 30 minutes, or I'll need 3 virtual network functions for next 10 minutes. So that is, so we use machine learning to know about that future and forecast. I'm assuming that it's okay if you don't know a lot about machine learning, but as long as you know that there is this input data, and then it can learn about things and forecast the future, predict the behavior of the data. That's enough. So then the second point is, how do we make changes to these physical resources? So the idea is that there will be this algorithm which will look into the prediction output and then make smarter decisions. So it will shut down things, move things around, and then take actions, so the network is auto-scaled, right? And then from here, with the whole circle we have, the problem statement kind of becomes two parts, that there is this prediction and there is this actual actions that we are taking using algorithms. So let's talk a little bit about the prediction. So traditionally what we see is this threshold based approach, that you look into some threshold, let's say the information or the workload is going from 7 to 8, so it crosses my threshold, so I need to add one more VM. So that was the idea. And there are many research works which looks into threshold based approach for even for network component management, network resource management. Then there are many limitations of that kind of solution. So we kind of try to go ahead of that and see if the machine learning prediction. So intuitively it is supposed to help, but as you will see later that machine learning should help, machine learning should know the future, is not necessarily a truth for all the scenarios. So we go ahead and explore how machine learning based prediction can perform using one of the data sources that are publicly available and used for network traffic prediction and such. So initially we are looking into number of virtual network functions that we'll be using to auto scale, right? So the idea is that depending on your traffic, let's say 7 a.m. in the morning, you don't have that much people using the network, so you will need, let's say, 3 virtual network functions. Then 10 a.m. you will need 5 virtual network functions. Then in the midday, everyone is up and working, so you'll need 10 virtual network functions. Then later in the day, let's say 8 p.m., then everyone is leaving the network, and then you don't need 10 virtual network functions. Let's say you don't need 10 firewall, right? So that is the idea. And then if we train the machine learning model from the data from all over these days, for day 1, day 2, day 3, over the time we see that the prediction model starts doing better with more data. Again, that is not always true, but in our scenario we do get this kind of improvement over the training data. So that motivated us to kind of go ahead and explore more in this direction. So we were using, as I mentioned, that we were using this data collected every 5 minutes. So granularity is important because if the data is being collected, let's say once a day or twice a day, that is not very helpful to do this kind of dynamic resource management, right? Where you need to make a decision every 10 minutes, every 5 minutes. So we use this data, which is was collected every 5 minutes over a pretty good enough length of time, and have been being used in other studies as well for traffic prediction. And then we look into the features that, okay, what are the temporal information which are there, the traffic measurement information, and try to extract informative features out of it. And then we find that out of exploring different machine learning models, the prediction accuracy of random forest algorithm was pretty high. And then we did not stop there. We reported comprehensive analysis of the performance of different algorithms, different performance metrics like precision, false positives, ROC area. I would not worry much about if you are not familiar with these terms. Imagine that there is these different algorithms which can do prediction in different ways, and there is this different metrics to tell that, hey, my prediction is better than the other prediction. So we explored in those direction, and many of the research work we see so far today in especially in the networking world kind of stops here. They will be like, hey, I have this data, I did some prediction machine learning model, and I see that this is going in a good direction and I'm reporting it in my research, right? Then we were thinking, what can we do more in this direction to help the other researchers to understand, or help the practitioners to implement this machine learning model? So we explored kind of trying to make that machine learning black box more understandable. So we explored the learning curve analysis of varying number of features, number of data set size. We did feature ranking, trying to understand which features are helping with the forecasting more and how they're correlated. Impact of different sets of features. What if I only have this side of the data, not the whole data, and such. And training time, testing time. So as much as we can report, as much as we can dig into the machine learning sandbox and try to understand and bring that to the research community. So that solves our problem of knowing the future, that, hey, now I know that next 10 minutes I will need 5 virtual firewalls. Okay. And then from there, we were trying to incorporate that in a real world problem, that, okay, knowing the future is good, but then how it is helping me to auto scale the resources. So for that, we bring in this this scenario, which is called service chains. It's again a concept in networking where you will see this. If we follow one of these, maybe this blue line, the idea is that so this node 6 in the network is Texas El Paso, let's say, and then you have a central office or branch office which needs to be connected with the headquarters in node 1, Seattle, Washington State. And then what will happen is that bank or Netflix or that tenant will come to AT&T network operator and say that I need this connectivity between Seattle and El Paso, right? And then it will be like, I need this firewall. The tenant will ask that I need this firewall, I need these routers, I need this bandwidth capacity, and please deploy my network capacity, and I'm willing to pay for that. And then the network operator will go and deploy these chains of services, which goes from node A to node B and connects the network. So that is how the services for the tenants, enterprise tenants. For us users, regular everyday customers, it's the network is there and then I get connected from my home. But for the enterprise tenants, it is this chains of services which will be deployed with guaranteed capacity, guaranteed devices and such. So we take that scenario and combine it with our machine learning solution that we proposed. So we propose a new algorithm which uses the machine learning based prediction and tries to auto scale these service chains that we talked about. So Bank of America has this service chain from Seattle to El Paso, and then it is traditionally what will happen is that whole resource is there all day, 24/7, all year, and it is not auto scale. But we are proposing that, hey, let's auto scale that resource. When the bank needs the bandwidth, we give them the whole bandwidth. If it's not needed, then we reduce it. And how do we know if we'll need how much resource? We use the machine learning model. Okay. Um, and then we see that the cost for the tenant, the Bank of America, can go down to 42% compared to other studies who proposed other solutions. So imagine that you are paying $1 million per year for the connectivity, and then the cost goes down 42%. That is almost half of the cost saving using this kind of auto scaling method and network automation proposed by our solution. We explore another direction of this problem, which comes from the fact that the tenants in an auto scaling environment will have a different level of sensitivity. Let me kind of elaborate on that. In many cases, we would assume that the tenant wants to auto scale, but that may not be the case, right? For example, let's say YouTube. YouTube is a free service. Then YouTube service provider, let's say Google, may not be that sensitive to reduce the number of resources that they have deployed. On the other hand, let's say Netflix or Bank of America, they're paid service. Their tenants are, their customers are kind of using more sensitive information, more paid information, more paid subscriptions. So in such scenario, they can be not so interested to auto scale. They will auto scale only when it's very much safe and such. So there is different level of sensitivities. And then that brings us to different level of refund that you can get from the network operator, right? And then from an operator's point of view, the operator, the owner of the network, will always try to give you minimum refund, right? What's the point of giving you back a lot of money? And then they still have to respect that sensitivity of the tenants. So this brings kind of a game theoretic aspect between the tenants and the operators, and we explore that direction. And then we propose this new algorithm which presents a win-win solution for both tenants and the operators in terms of saving the cost, in terms of the resource usage inside the network. So without going into that algorithm and showing you a lot of equations, I want you to bring the overall idea out of this presentation that the auto scaling is helping, machine learning is helping in the auto scaling process, and in that process we are seeing that there is this interesting algorithmic aspects as well, where eventually we are saving lots of, we're making the operators happy, tenants happy, and saving lots of money. So to summarize the prediction accuracy that we have observed so far, it goes up to 96.6. It is relatively a good number, but I hope that future studies will kind of try to propose newer methods and improve on that number. And the cost saving is a very big motivation for further study. Our proposed negotiation game based algorithm presents a win-win solution for both the tenants and operators, and motivates for more further study in this direction. There can be many future works around this area of research. We can talk about virtual scaling versus horizontal scaling. We can look into auto scaling for this kind of edge cloud environment where you have these mini data centers and you have this network / cloud components. We can explore other learning methods, which essentially we did in one of the studies with Mahmoud and Adnin Madam and Zakia. We were looking into this similar problem with more focus on deep learning and long short-term memory and such, which was an excellent direction to go into. So this work was initially presented on IEEE ICC and then extended with the negotiation game and service chaining in IEEE transactions of network and service management. Okay. So moving on, hopefully that was not a lot of new things, and kind of gave you some idea what kind of resource management problem we can help in using data-driven solutions like machine learning models and such. This next study, which I will be going over rather in a higher level, looks into electricity data, which is a very interesting source of data. It's not from network, it's not from data center, but it helps to reduce the cost of data center management. So when we talk about data center, we often forget that it's essentially a large complex network which is placed together for efficient data handling, cloud service providing, and such. So all of these geo-distributed data centers, which comes from all of these big data center service providers or communication service provider, like it may sound surprising that, but essentially today what Google and Facebook is doing is providing us communication over email, over Facebook Messenger and such. So in a sense, they are communication and software company. So they have this large distributed, again, footprints of data centers. Sometimes they're very large data centers, sometimes they're smaller footprints, but they still have these data centers which are distributed all across the world, and then they're connected with each other, right? So electricity cost is a big, I used to have the actual numbers in dollars, how much it costs. So it costs in terms of millions per year for each of these companies, just for electricity cost out of the data center. So if you can save, again, 5%, 10% of that cost, 20% of that cost, that's in terms of millions of dollars saved per year. So that is, again, another motivation to look into this area of research. So the motivation comes from this variable electricity cost that changes over time and over location. Here, these are in continental US. Here we are looking into let's say Kaizo is in California and ERCOT is in Texas. So these are service providers, electricity, who sells electricity to the customers in that area. So in Texas, you will get electricity from ERCOT. In California, you get electricity from Kaizo. And then as the graphs goes up and down, we can see that at a different time of the day, the electricity price is different. So it can go up, it can go down in different locations. So that brings us the idea that why don't we place at a certain time of the day, why don't we place the virtual machines inside the data center in the cheapest location? And that will over the time give me an overall lower electricity bill because I'm always picking the cheapest location. So that is the initial idea of this research. So the key concept, kind of to summarize, um, is the idea is that the electricity price is changing in place in time, right? And then we have this option of placing my workload, data center workload, in different locations because I have these geographically distributed data centers. So if Texas is cheaper in the morning, I'll place my VM, I'll run my VM, whichever task I'm doing. I'm serving customers, I am storing backup data, whatever I'm doing, I can do it in Texas data center. And that will give me cheaper electricity bill. If there is no other constraint, let's say user is in a place where in California, so they want the VM closer to them. If there is not like a delay constraint or something, we can pick the cheapest location. And then we talk about this live VM migration, which allows you to move already running services. Let's say in the morning, California was cheaper, so you placed your virtual machine in California. Then later in the day, let's say midday, California cost is very high, but the Texas is cheaper. So you can move your virtual machine, which is already running, to Texas. And using this live virtual machine migration, the user who is using the VM won't even know that the VM moved. So it is live, and it's a new technique that allows the data center managers, admins, to move things around without interrupting the quality of service, without interrupting the user. So that is something we use in our study to optimize things more. So one thing is I can choose the cheapest location. The other thing is if later in the day another place is cheaper, I can move my VM there. So that is helpful. In terms of other contributions, power model we look into. So traditionally in the cloud world, network is much ignored. It is all about compute and storage. So the power model in the other studies that proposed in this direction ignores the network power consumption. So they mostly talk about server power consumption, VM power consumption, and such. So we bring that aspect into this area of research. So in the overall scenario, we see that this network, these data center users are coming in, then we look into the data center capacity, we look into the network state and link capacity, we look into the electricity price data, we look into the delay constraint that, hey, you cannot move this service very far away from the user, and try to propose a dynamic optimization method, an algorithm, which decides that this location is the cheapest, or this service which is currently running needs to be moved to that other location which is cheaper. And in this process, we demonstrate that in some cases, you can save up to 32% of electricity cost. So that is a large amount of, again, monetary benefit for uh, the data center service providers. So this study was published initially, it was presented in IEEE ICC in 2017, and then later got published in IEEE Transactions. Again, this study has many future directions. In some markets, the electricity price is not forecasted ahead of the time. In USA, the electricity service provider, let's say Kaizo in California, will give you a price prediction 24 hours ahead of the time. But in some markets, that is not the case. So in that kind of scenario, we can do electricity price prediction and see if that prediction is helping in this process, right? Our research talks about virtual machines only, but in recent times, there is this big move towards container-based virtualization, Docker containers and such. And what's the impact of that kind of virtualization in this kind of research problems? That can be an interesting direction. There is this there is this complexity that can go on with the cloud service provider who owns the VMs and wants to move the VMs around. And then there is this network service provider who owns the network which the VMs are moving around through. And there can be an interplay, excellent, another game theory aspect which can be brought together in this kind of research problems in future. So yeah, moving on, I would like kind of quickly want to spend some more time in one or two of other research problems. So those two, the first one was we were using machine learning, using the collected data and trying to automate. The second one, we are not doing machine learning, but still data is helping. So we propose the data-driven algorithm, and that is helpful. That has been demonstrated to be helpful for automation of this virtual machine resource management in cloud data center network. And then this third one focuses on analysis of data. So it is not essentially doing any forecasting or resource management, but we are trying to look into a data set and trying to understand the insights from the data, what we can learn about the network usage, users, and such. So in this study, we look into, with the motivation was that we want to understand how video traffic is working inside the network. So we use this video streaming data, which comes from a streaming service in South Korea. We had this visiting professor at UC Davis who had access to that data. The company is, imagine Netflix in South Korea. So they do content service providing and they do lots of streaming. And to give you some introduction about the data, it looks into live channels data, movies, and other VOD, video on demand contents. And it has interesting information like how long did you watch, or what kind of program did you watch, what kind of device the user were using, what kind of bit rate in terms of network bandwidth capacity, master IP address, and some user related information like the gender or age group and such. So then the idea of this research contribution was that what can we learn more that we do not know about this kind of video streaming environment. So we tried to gather insights on user information, for example, analyzing the user profile, which age group is viewing when, temporal patterns of the viewing activity, when do the users watch more video, what kind of video, news or movie, something like that. User device, what kind of devices are being used. The most interesting, I would say, is video browsing behavior, that how can we correctly classify the video browsing behavior. We talk about early leaving when the user turns on this movie and then they're leaving. A steady viewer when the user turns on this movie and then they're watching it for a long time, right? Then we talk about surfing users who are surfing through the videos. They're not watching the whole thing. They're kind of clicking through it. And then how do we kind of classify them and which number is bigger and such, that kind of reporting. Again, this research can go beyond just analysis. It can be used for prediction of user behavior. If I knew that this user will be watching this movie for a longer time, then that will help in network resource management, that will help in caching and a lot of things. Another interesting direction, which is a future work, and I kind of want to work on this direction in future as well, is privacy preserving data analytics. So this kind of data can have privacy sensitive information, and how we can analyze this data without giving away too much information about the user. Data-aware resource management is another direction which this study can go. I have one more researcher. I kind of want to go in a higher level. So this talks about, again, virtualized controller placement. So essentially virtualized network resource manager, virtualized network controller, which will be deployed in a large multi-domain transport network, again, large scale network using machine learning. So this study was looking into, maybe a brief introduction will be okay with the time. It looks into the concept that we have, because of the SDN, software defined network, we have these controllers which talks to your switches and manages the switches. So the switches are being more of a device that does the switching, but it does not take a lot of decision. It always talks to the controller to make routing decision, hence the idea of SDN, right? That idea is more dominant in the data center area, but in the transport network, the large scale backbone network that we have been talking about so far, the SDN is just coming in. So, main reason is the devices are very much traditional. Most of the devices are back from the 90s and 2000s, so you cannot really do SDN with them traditionally. But we are bringing in new technologies. So today we have this OpenFlow Plus, which does optical transport network SDN and such, and they're evolving, right? So this research talks about that kind of scenario where we'll see SDN kind of controller in optical large scale transport network. And then we are proposing that if we have virtualized controllers, which means the controller instance will be running on top of VM instead of a physical box controller, then we can do a better job in placement in a dynamic way. And that saves a lot of resources in terms of money and such. So this work was presented in ONDM and then later got invited in Journal of Photonic Network Communications, which got published this year. So again, this work has many aspects which can go into the future work, yeah, I am very positive about this work as well. So this was my 4 contributions in my PhD. Hopefully it was not too much detail, but it's still motivating in terms of data, in terms of how machine learning can help, in terms of how there are many interesting resource management problems that can be addressed using this kind of data. I want to talk a little bit about one or two of the projects that with AT&T Labs that kind of may bring in more interest and motivation in this area of research. So in my first summer with AT&T in 2016, I was working with this team who were deploying virtualized network components inside the network. So the team was responsible for bringing in virtual nodes, virtual machines, virtual firewalls. Think about these VM boxes, which handles network traffic, right? And then there was a problem. What happens is these traditional hardware boxes are more robust. They're tested more. They have been around for years. The software is designed to work with the hardware, and for many reasons, they fail a lot less. But these virtual nodes, virtual machines, virtual firewalls, they keep failing. So there will be this software, patch problem, there will be this connectivity issue, and they will fail, they will crash, right? The VMs will crash, the software will crash. So when something fails, an administrator will have to kind of go into the problem and reboot the VM or something like that. So our idea was that, can we do something about that? How can we help? So the first intuition is, can we predict the failure before happening? So that will at least give the network admin some heads up, right? That, hey, that node is going to fail, you better reboot that VM or something like that. And then if we can predict, that recovery process can be automated. So if it's as simple as rebooting the VM, you can write up scripts that can automate the rebooting process, that you don't need a human intervention. So in this, during that summer, we tackled the first one, that can we predict the failure ahead of time? And there were lots of collected data from the virtual nodes. So we trained machine learning models in Python and explored different machine learning algorithms and try to see if it helps. So in terms of output, we saw that yes, in 96% cases, you can actually accurately tell that something is going to be wrong. So let me give you some idea on the data part, what kind of data was being collected. So we were looking into the status of the VM, right? So we will be looking into the CPU usage of the VM, memory usage of the VM, network connectivity, so how many packets going in and out, and many such parameters. There are like 27 parameters which were being collected from the nodes, and they kind of help us to predict the failure ahead of time. And another good thing is, on average, we could do it in 3.2 minutes ahead of the event. So that is enough time for a computer to fix that if the computer knows what to do. That is not enough time for a human, but it's relatively nice heads up for a network admin to take necessary action, at least start on the necessary action. I'll skip the second one and talk a little bit more about research and collaboration and future direction. So inside UC Davis, I have collaborated kind of away from the network area and inside other areas of network resource management. I've worked with IoT mobility forensics. It looks into IoT data, that IoT device data that is being collected from a digital forensics point of view. So in terms of what kind of data are being collected, how it can help in forensics, digital forensics study and such. We talk a lot about 5G and different components of 5G. These days, we're going into 6G, edge computing, next generation evolution of the optical networks, data center networks, as I mentioned, many of my works looks into such scenarios. Um, in our lab, we talk a lot about disaster recovery and restoration. We have had many different funded projects. We talk about what happens if your network is not working in a large scale manner, let's say some hurricane or earthquake or something like that. How do you go about recovery and restoration? We talk about smart city applications, smart city communication from a protection and recovery perspective. So there are a lot of additional directions of importance, of interest, and in addition to my research, I have been involved in many of these activities. Mostly to, again, I am going through it. It can be a lot, it may sound like a lot of things, but again, the purpose of mentioning all this is to kind of give you a highlight of there is a lot to be done, and we always appreciate and welcome more and more researchers interested in this area. Some other words, I collaborate a lot with, most of these are connection through UC Davis Research Lab through Professor Mukherjee. And I have been working in quantum networking. I have worked in reinforcement learning, application of reinforcement learning. A new area I'm working these days is knowledge graphs. So how you can represent the human kind of understanding. We correlate things with one thing with another. Like, for example, in the case of failure detection, we correlate that, okay, this virtual machine is with this server machine, and then these softwares are interconnected, and that is why the failure happened. So that kind of human understanding can be represented into knowledge graphs, and that helps in, let's say, in failure, understanding where the failure happened. Yeah, so one thing I want to highlight is my recent collaboration with Mahmoud Madam and Zakia with PUED. We work on these very exciting research problems, which does forecasting, prediction of virtual network function requirement using deep learning, long short-term memory, and it has been accepted in IEEE GlobeCom 19 with some really positive reviews, and we actually are submitting the journal version of it in recent times. So this to showcase that in today's world, collaboration has become very easy. We can actually create a global scale collaboration without actually meeting one another in person. So that is something I would encourage uh, 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 for the faculties and researchers and graduate students, undergraduate students to take advantage of this situation that today with virtual communications, it is possible to engage in cutting edge research, collaboration together, submit papers, and then get accepted in good venues. So that is exciting, and I hope out of this talk, we will create more collaboration and activities, especially with WIT. So in terms of where I see the research going on. That is kind of the wrapping up version of my talk. I see that the emerging communication systems will be a big part of the evolution that we are seeing. Today, we talk a lot about edge computing. IoT have been around for a while, but today, when we mix up the IoT in terms of industry 4.0, 5G, it is a different type of IoT. Yeah, sometimes it's referred to massive IoT, that you will have billions of devices and they will be dumping tons of data. So that is from a communication point of view, not from the point of view that what the device is doing. From a communication point of view, it is a challenging problem. Satellite networks are more and more satellite networks are going up, and they have a different kind of interesting direction that can be exciting in future. We have started talking about 6G, what it will be in 6G and such. Quantum networking is coming up, and it is going to be a lot bigger when we have more and more quantum computers up and running. Then we see a lot of inter-domain research inside CS and going beyond CS. So we see a lot of collaboration going on, AI, machine learning, cybersecurity, and all of these are coming into the networking area as well. So I see that there will be more of these mixes. And of course, as in terms of personal growth, I see myself going into more and more knowledge domains, working with more and more researchers. And of course, I encourage all of you to reach back with your thoughts, with your ideas, and hopefully we can work on some of the collaborative aspects of the research. So with that note, I will kind of wrap up. So my LinkedIn link and Google Scholar profile is here. Feel free to look into my other research works and projects as well. So thank you for spending the evening with my talk. And if you have questions, I am here.
Thank you, Sabidur. We will now take questions. I can see Pritam Shah Orko আমাদের এখানে lecturer. So Orko হাত তুলেছে, তো Orko query করো তোমার 2013 ব্যাচের হচ্ছে গিয়ে ফার্স্ট আর কি, সে আমাদের এখানে লেকচার হিসেবে কাজ করছে। তো অর্করও গুড পাবলিকেশন আছে, সে মেশিন লার্নিং, ডেটা সায়েন্স এসবে কাজ করে ইউনুসের সাথে। তো অর্ক কথা বলো, তোমার কোয়েশ্চেনটা করো।
অর্ক মনে হয় ম্যাডাম নাই,
যে হাত তোলা দেখতে পাচ্ছি।
অসুবিধা নাই। আচ্ছা, আর কারো কি কোনো কোশ্চেন আছে? কোশ্চেন করলে থাকলে একটু আইদার চ্যাটে টাইপ করলে হবে, অথবা হ্যাঁ রাজীব ভাই শাবাশ, আপনি মাল্টিপল কোশ্চেন করতে পারেন একবার।
আসসালামু আলাইকুম। আমি সরি, আমি আসলে টকের কিছু শুনি নাই, আমি পুরো রাস্তায় ছিলাম, জাস্ট এসে লাস্টের কাপল অফ স্লাইডস দেখতে পারছি। এন্ড গ্রেট টু সি।
রাজীব তো অনেকগুলো পছন্দের এরিয়া ছিল, যাই হোক
লাস্টের দুটো স্লাইড আসলে খুব পছন্দ হয়েছে আমার। তো আমি আসলে যে জিনিসটা জিজ্ঞাসা করতে,
হ্যালো,
কানেকশন মনে চলে গেছে নাকি?
আপনি যেহেতু নতুন ফ্যাকাল্টি হিসেবে জয়েন করতেছেন, আমি নিশ্চিত যে আপনি এনএসএফ এবং এনআইএইচ বা অনেক জায়গাতে ফান্ডিং এর জন্য কিন্তু পার্সু করবেন। এবং আমি যদি ভুল করে না থাকি, বেশ কিছু এখন ইউএস এর মানে ফান্ডিং এজেন্সি আছে যারা শুধুমাত্র উইদিন ইউএস না, উইদাউট ইউএসও এখন বিভিন্ন ধরনের কোলাবোরেটিভ রিসার্চকে ফান্ড করে। তো এই জায়গাগুলোতে আমাদের দিক থেকে আসলে বহু ল্যাকিংস আছে, আমি বলার আগে স্বীকার করে নিই। তো আমরা কিভাবে আমাদের ল্যাকিংস গুলা কাটায় উঠতে পারি, এবং আমাদের যারা ভেরি অনারেবল ফ্যাকাল্টি মেম্বার্স বাইরে আছেন তাদের সাথে কিভাবে আমরা জয়েন্ট রিসার্চ প্রপোজাল ফর ফান্ডিং পাবলিকেশন, আমার কাছে এটা ইটস মাই পার্সোনাল বিলিফ, আই মাইট বি রং, আই অলওয়েজ থিঙ্ক দ্যাট এজ এ বাই প্রোডাক্ট। সো একটা জিনিসকে ম্যাটেরিয়ালাইজ করার জন্য আসলে ফান্ড লাগে। আমাদের স্টুডেন্টরা তো আসলে বাতাস খেয়ে বাঁচে না, তাদের তো একটা লিভিং লাগবে। সো আমাদের ফান্ড না থাকলে আমাদের স্টুডেন্টদেরকে কিন্তু আমরা গুড রিসার্চে ধরে রাখতে পারি না। আবার বাংলাদেশের ভিতরে ফান্ডিং অপরচুনিটি খুব লিমিটেড। সো আপনাদের সাথে কোলাবোরেট করে আমরা কিভাবে জয়েন্ট রিসার্চ প্রপোজাল ফর ফান্ডিং এই জায়গাগুলোতে পার্সু করতে পারি, একটু যদি প্লিজ বলতেন।
হ্যাঁ, থ্যাংক ইউ ভাইয়া। তো অবশ্যই আপনি যেটা মেনশন করলেন যে ফান্ডিংটা খুবই ইম্পর্টেন্ট, এবং আমি দেখি যে অনেক কোলাবোরেটিভ ফান্ডিং, যেমন রিসেন্টলি আমরা একটা মানে আমরা বলতে আমাদের ইসিডিভিসের ল্যাবে একটা ফান্ড আসলো যেটা হচ্ছে জাপানের সঙ্গে। সো এনএসএফ আর জাপানের কোলাবোরেশন, জাপানের এনআইসিটি এর কোলাবোরেশন। সো আমার মনে হয় যে এরকম আরো কোলাবোরেশন স্পেশালি বাংলাদেশের সঙ্গে একটু পিছায় আছে আমি যতটুকু দেখি। ইভেন আমি বাংলাদেশি হিসেবেও অনেকখানি পিছায় আছি কোলাবোরেশনে বাংলাদেশের সঙ্গে। তো আমার মনে হয় যে there are a lot of opportunities in this area, and অবশ্যই ভবিষ্যতে আমরা ফান্ডিং প্রপোজাল এ ধরনের অপরচুনিটির ক্ষেত্রে এক্সপ্লোর করতে পারি অবশ্যই।
আমার যেটা মনে হয় আমরা উই নেভার এক্সপ্লোরড আসলে ইনিশিয়েটিভটাই কিভাবে দুপাশ থেকেই করতে হয়। ধরো ওখানে যারা আছে দে উইল অলসো পারসু, এন্ড এখানে যে গ্রুপ অফ ওয়ার্কার রিসার্চার আছেন মানে তাদের কথাটাও বলা, এবং তাদের কিছু ভালো ভালো কাজ ভালো ভেন্যুতে তাদের কাজ আছে, তো ওগুলো দুপাশ থেকে আসে। তো ওই যেটা আর কি আসলে আমরা তো নিউ বিকজ হচ্ছে অন্যান্য কান্ট্রি ইন্ডিয়া চায়না 50 ইয়ার্স আগে থেকে তারা ওখানে গিয়েছে এবং তারা হচ্ছে এস্টাবলিশড। সাউথ কোরিয়া তো অনেক এস্টাবলিশড। তো এইসব জিনিসগুলো আসলে আমার মনে হয় এখন আস্তে আস্তে হচ্ছে এবং হবে। ওই যে আউটরিচ আর সাবিদুরের প্রেজেন্টেশনে যেটা দেখলাম ওই যে ডেটা সেন্টার তো দেখলাম মাইক্রোসফটের মানে এশিয়াতে নাই ওরকম, তাই না? মানে বেশি তো দেখলাম সব হচ্ছে ইউরোপ অ্যান্ড যেটা হচ্ছে নর্থ আমেরিকা। তো আসলে হয়তো দু একটা হলো মাইক্রোসফট এরিয়া হয়তো চায়না বা ইন্ডিয়া এরকম আছে, গুগলের তো সেটাও সেরকমও দেখলাম না, আছে কিনা জানি না। তো এই জায়গাগুলো তো আসলেই আমরা অনেক পিছানো। আর রাজির কথাটা খুবই ভ্যালিড। আমাদেরকে হচ্ছে মানে অনেক বেশি আসলে কি করে আসলে ইনভলভমেন্ট এটা বাড়ানো যায়। এবং আমরা আরেকটা জিনিস হচ্ছে সাবিদুর, আমার একটা কোয়েরি হলো এই যে ডেটা গুলো মানে এই তোমরা যখন কাজ করেছো যে মেশিন লার্নিং যখন অ্যাপ্লাই করছো বা বিভিন্ন প্রবলেম ডোমেইন নিয়ে কাজ করছো, সো ইউ গট দ্য ডেটা। সাপোজ হচ্ছে ওরা ডেটার জন্য অনেক ডেটা নিয়ে হয়তো AT&T বসে আছে, সো দে আর মানে তাদের রিসার্চাররা কাজ করতেছে। তো আমরা তো আসলে এই ধরনের হচ্ছে গিয়ে এগুলো আমরা পাচ্ছি না, যদিও মনে হয় যে অনেক বাংলাদেশে অনেক ডেটা আছে আসলে, কিন্তু সেইভাবে ইনফ্রাস্ট্রাকচার মানে ডিজাইন গুলো তো আমরা ওরকম করি না। আমরা কোনো নতুন সলিউশন দিই না, উই জাস্ট মেইনটেইন, উই জাস্ট বাই দ্য সলিউশনস and হচ্ছে উই ইউজ ইট and উই পে লট অফ মানি। অ্যাকচুয়ালি বাংলাদেশের ক্ষেত্রে নেটওয়ার্ক রিসার্চটা অনেকটা এরকমই। তবে কিছু কিছু এরিয়া এখন খুব মানে আমাদের দেশেও মানে খুবই ইম্পর্টেন্ট, যেমন হচ্ছে তুমি যেটা বলছিলে ডিজিটাল ফরেনসিক, মোবাইল বোধহয় বলেছিলে যে আইওটি, মোবিলিটি ড্রিভেন আইওটি বা এই ধরনের, এগুলো এখন আমাদের দেশে খুবই ইম্পর্টেন্ট। এবং আমাদের যদি এরকম ডিজিটাল ফরেনসিক প্ল্যাটফর্ম এগুলো ডিজাইন করতে হয়, আমাদেরও মানে খুব হাই লেভেল রিসার্চ লাগবে, এবং সেখানে কোনো কোলাবোরেশন থাকলে তো আরো ভালো, এই আর কি। তো ওই মানে ওই জিনিসগুলো কিভাবে সলভ করা যায় আই ডোন্ট নো।
তো আমি যেটা অ্যাড করতে চাই সেটা হচ্ছে নেটওয়ার্কের ডেটাটা আসলে এখনো বেশ চ্যালেঞ্জিং। মানে ইভেন ইউএসএ থেকেও আমরা খুব একটা ডেটার অ্যাক্সেস পাই না, কারণ আসলে পাবলিকলি শেয়ার করতে চায় না। এটা অনেক ক্ষেত্রে টেনেন্ট ডেটা থাকে, সো ওদের প্রাইভেসি ভায়োলেট হয়। সে কারণে ধরেন AT&T বা এরা খুব একটা ডেটা শেয়ার করতে চায় না। কিন্তু তার মধ্যেও কিছু ডেটা অ্যাভেলেবল আছে বা আরেকটু ওপেন এন্ডেড, যেমন হোপফুলি ইন ফিউচার লরেন্স বার্কলে ল্যাব, ওদের যে একটা এনার্জি সায়েন্সেস নেটওয়ার্ক আছে, ওখানে দ্যাট ইজ মোর রিসার্চ ওরিয়েন্টেড ডেটা, এবং আশা করি যে তারা হয়তো ইন ফিউচার আমার সঙ্গে ডেটা শেয়ার করতে ইন্টারেস্টেড হবে। কিন্তু AT&T-তে যেটা হতো যে ওদের সঙ্গে আমি যে প্রজেক্টটা কাজ করব সেটার সমস্ত ডেটা নট পাবলিশেবল, যেহেতু টেনেন্ট ডেটা। সো আমার যেটুকুন কাজ করতাম বা যা কিছু ডেভেলপ করতাম, দ্যাট উইল স্টে ইনসাইড AT&T। আমি ইভেন UC Davis-ও নিয়ে আসতে পারতাম না। সো দ্যাট ইজ এ চ্যালেঞ্জ স্টিল আউট দেয়ার। হোপফুলি সামনে এটা আরেকটু ইমপ্রুভ হবে এবং নেটওয়ার্ক অপারেটররা হয়তো আরেকটু ইন্টারেস্টেড হবে শেয়ার করতে, বাট সো ফার স্টিল ইটস ভেরি ডিফিকাল্ট।
আর কারো কোশ্চেন আছে?
আচ্ছা স্যার, আমি একটু আগে হ্যান্ড রেজ করেছিলাম,
হ্যাঁ,
আমি
অল্প
একটা কলে ছিলাম,
বলো বলো,
এই জন্য সরি। আসলে
অল্প বলো।
এখানে ওই মেইনলি দুটো জায়গাতে কিছু প্রশ্ন ছিল। একটা হচ্ছে ভিডিও স্ট্রিমিং ডেটা থেকে যে কাজটা, সেখানে যে প্রেডিকশনের যে কাজগুলো ছিল, লাইক ইউজাররা কোন টাইপের কন্টেন্ট পছন্দ করে, অথবা কোন ইউজার কতক্ষণ পর্যন্ত কোন ভিডিও দেখছে, কে কোন টাইপের কন্টেন্টের জন্য পে বেশি করছে, এরকম নানান রকম ডেটা থাকতে পারে। এখন এই ডেটা তো, এই ধরনের কাজ তো ইউটিউব আমি যতদূর জানি যে বেশ অনেক বছর ধরেই করে আসছে। তো ওইটার সাথে আপনাদের কাজটার ডিফারেন্স বা সিমিলারিটি আসলে ঠিক কোন জায়গাগুলোতে ছিল, এটা হচ্ছে আমার ফার্স্ট কোশ্চেন। আর সেকেন্ড যে কোশ্চেনটা ছিল যে নেটওয়ার্ক ট্রাফিক এস্টিমেশনের যে কাজটা করেছেন, সেখানে কি আপনারা যেই লং টার্ম যেই ডিপেন্ডেন্সি, মানে হচ্ছে আজকে সকাল 9টা থেকে রাত, সাপোজ আমি রাত 9টার সময় আমি প্রেডিকশন করতে চাচ্ছি যে রাত 10টার সময় আমার নেটওয়ার্ক ট্রাফিক কেমন হবে। সো এখানে তো আসলে আমার হোল্ডের নেটওয়ার্ক ইউসেজের উপরও আসলে ওইটার একটা ইম্প্যাক্ট থাকবে। সো হোল্ডের এরকম লং সিকোয়েন্সের ইনফরমেশন ক্যাপচার করার জন্য সাধারণত আমরা LSTM ইউজ করি এখন। সো আপনারা কি আসলে সেই LSTM ইউজ করেছেন, নাকি এটার কোনো মডিফাইড ভার্সন বা অন্য কোনো কিছু ইউজ করেছেন?
হ্যাঁ, দুইটা খুবই ভালো কোয়েশ্চেন। আমি শুরু করি প্রথমটা দিয়ে। সো যে ভিডিও ডেটা, যেটা আমাদের ওয়ার্কটা ছিল মোস্টলি ডেটা অ্যানালিসিস এবং ডেটার ইনসাইট শেয়ার করা। প্রেডিকশনের সাইডে আমি যেটা মেনশন করেছি সেটা হচ্ছে ফিউচার ওয়ার্ক হিসেবে। তো অ্যানালিসিসে প্রথমে বলি যে অ্যানালিসিসের যেটা হয় যে বিভিন্ন সময় বিভিন্ন সোর্স থেকে ডেটা আসে, যেমন তুমি ইউটিউব করে বললাম, ইউটিউব মেনশন করেছো। সেখানে ইউটিউবের ডেটা ওরা যখন অ্যানালাইজ করে একটা জিনিস রিপোর্ট করছে, দ্যাট ইজ নট নেসেসারি ইউনিভার্সাল, ইউনো। এই ধরনের অ্যানালিসিসের অনেক রেজাল্ট আছে ধরো 2011-তে। তো 2011-তে স্মার্টফোন মাত্র এসেছে, ওভাবে ভিডিও কন্টেন্ট নাই, নেটফ্লিক্সও ওরকম নাই। সো সেই সময় অ্যানালিসিসটা এখন আবার খুব একটা অ্যাপ্লিকেবল না। সো সে কারণে আবার রিসেন্ট অনেক স্টাডি হচ্ছে, ধরো LTE আসার কারণে, 5G আসার কারণে। সো এভাবে স্টাডি চলতেই থাকে। সো দ্যাট ইজ দ্য মোটিভেশন এন্ড ইনোভেটিভ পার্ট নোভেলটি এর, যেটা যে ওকে আবার বুঝতে চাই আমরা হোয়াটস গোয়িং অন নিউ। আর প্রেডিকশনের যেটা ফিউচার ওয়ার্কের ডিরেকশন বলেছি, অবশ্যই অনেক ধরনের কাজ আছে, সে বিষয়ে সন্দেহ নাই। কিন্তু সেই জন্যই আবার ওই এরিয়াটা রি-এক্সপ্লোর করা, যে হোয়াট ক্যান উই ডু মোর, হোয়াট ক্যান উই ডু নিউ, সেটা ফিউচার ডিরেকশনে। যেমন ভিউয়ার অ্যাক্টিভিটি এর যেটা ট্রেডিশনালি যেই রিসার্চ ওয়ার্ক গুলা আছে, দে লুক ইনটু আর্লি লিভিং আর স্টেডি ভিউয়ার, যে কে এসেই চলে যাচ্ছে, দ্যাট মিন্স সে ভিডিওটা লাইক করেনি, অথবা স্টেডি, দ্যাট মিন্স দে লাইক দ্য ভিডিও। সেটার পেছনে অনেক কাজ আছে, আমরা দেখতে পাই লিটারেচারে। কিন্তু আরো নতুন ধরনের ভিউইং অ্যাক্টিভিটি চলে আসছে, যেটা স্পেশালি নেটফ্লিক্স এর কারণে, যে সার্ফিং ভিউয়ার, যে ইউ আর গোয়িং থ্রু মাল্টিপল ভিডিওস ইন 5 or 10 minutes, অর তুমি টেনে টেনে দেখছো একটু পর পর, সেটার টেকনিক্যাল নামটা আমি ভুলে গেলাম। সো সেই ধরনের ভিউইং অ্যাক্টিভিটি আগের স্টাডি গুলাতে দেখা যায় না। সো দেন আমি এখন যখন নতুন করে প্রেডিক্ট করতে যাব, নতুন প্রেডিকশন মেথড ইয়ে করবো, নাও আই এম ডুইং 4 ক্লাসিফিকেশন ইনস্টেড অফ 2। সো সেখানে থেকে নভেলটিটা আসবে, নট অনলি ফ্রম দ্য মেথড এন্ড দ্য ডেটা। তো এরকম অনেক নতুন ইন্টারেস্টিং ডিরেকশন আছে, মানে ইনোভেশন বা নতুন জিনিস অ্যাড করতে চাইলে নতুন ডিরেকশন এক্সপ্লোর, এভাবেই তো আমরা আসলে নলেজ ডোমেইনটা এক্সপ্লোর করি। there are works but there are a lot of things to do new. নেক্সট পয়েন্ট হচ্ছে লং টার্ম এবং শর্ট টার্ম। হ্যাঁ, আমার স্টাডিতে আমি মোস্টলি শর্ট টার্ম, যে ওকে নেক্সট 10 মিনিটস, নেক্সট 15 মিনিটস এ কিরকম হচ্ছে। লং টার্মের জন্য আমরা যে জাকিয়া এবং মাহমুদা নাদিন ম্যাডামের সঙ্গে যে কোলাবোরেশন, ওটাই আমরা এলএসটিএম ইউজ করেছি এবং সেটাও বেশ ভালো পারফরমেন্স শো করেছে। সো ইউ আর রাইট যে শর্ট টার্মে এক ধরনের পারফরমেন্স আমরা আশা করি, কিন্তু লং টার্মে সেটা কি ভালো হবে কিনা, বাট ইট টার্নড আউট দ্যাট ইজ গোয়িং প্রিটি ওয়েল অ্যাজ ওয়েল। সো I hope that answers your.
Okay, thank you.
একটা মজার ব্যাপার সাবিদুর, সেই ডেটাটা আমরা যেটা নিয়েছিলাম, দ্যাট ডেটা এখন আবার অ্যাভেলেবল না, তখন অ্যাভেলেবল ছিল। মানে খুবই চ্যালেঞ্জিং ডেটা পাওয়া, আসলে খুবই চ্যালেঞ্জিং। আরেকটা হচ্ছে যে ইউটিউবের যে বিহেভিয়ারাল যে অ্যাক্টিভিটি, ইট হ্যাজ বিন চেঞ্জিং আ লট, তাই না? আমারও যেটা মনে হচ্ছে যে আগের মতো নাই। সো দেয়ার আর নিউ প্রবলেমস ইন দ্য রিসার্চ ডোমেইন।
এখন ম্যাডাম যেমন আরেক ধরনের ইউজার আছে, যেমন আমি আমার নিজের পার্সপেক্টিভ থেকে বলতে পারি, আমি অধিকাংশ ভিডিও আমি 1.25x 1.5x অথবা 2x স্পিডে দেখি। সো এই ধরনের নতুন ইউসেজ প্যাটার্ন হয়তো সামনে আরো ইমার্জ করবে, যে যারা আসলে অনেকে দেখতে চায়, অনেকে এমন, আমি অনেক ইউজারকে মানে ইউজার বিহেভিয়ার দেখেছি যারা হচ্ছে কোন একটা ভিডিওতে আসলে কি আছে সেই জিনিসটা ফার্স্ট 10 বা 15 সেকেন্ডসে যদি ভিডিওতে বলা থাকে তাহলে তারা শেষ পর্যন্ত অ্যাটেনশনটা রাখে। বাট ওই কোন রকম ওই সামারি টাইপের কোনো কিছু যদি শুরুতে বলা না থাকে, তারা আসলে দেখা যায় ওই ভিডিও জাস্ট 10-12 সেকেন্ড দেখেই তারপরে যখন দেখে যে এখান থেকে আমি ইন শর্ট কিছু পাচ্ছি না, দে জাস্ট লিভ।
সেটাই। খুবই ভালো লাগলো। সো আর কারো কোনো কোয়েরি? অনেকক্ষণ হচ্ছে কি সময় দিলে সাবিদুর, সো ইটস অলমোস্ট 2 hours. খুব ভালো লাগলো, এবং উই উইল কোলাবোরেট ইন ফিউচার আরো নতুন নতুন এরিয়া নিয়ে। আমাদের গ্রাজুয়েট স্টুডেন্টরা আছে, আন্ডারগ্রাজুয়েট স্টুডেন্টরা আছে, and Sabidur is very open for research collaboration. He's very very talented and helpful person. So we will keep in touch. আর আজকে তাহলে আমরা এখানেই শেষ করছি। থ্যাংক ইউ সাবিদুর। আর এসিএম চ্যাপ্টারের পক্ষ থেকে আমি আতিফ, রিফাতকে অলওয়েজ হচ্ছে গিয়ে থ্যাঙ্কস জানাই, আর আমাদের ডিপার্টমেন্টের হেড এবং বাকিরাও যারা পার্টিসিপেট করছে। সো এখানে শেষ করছি আর কি। তো আমি সাবিদুরকে ক্লোজ করতে বলছি আর কি।
থ্যাংক ইউ সবাইকে জয়েন করার জন্য। থ্যাংক ইউ এসিএম চ্যাপ্টার আমাকে ইনভাইট করার জন্য। Hopefully I will be in touch and talk about a lot more. With that, goodbye and good night.
Yes, all stay safe. তাহলে এখানে সাবিদুর শেষ করছি, তাই না? ঠিক আছে, বাই, আল্লাহ হাফেজ।
আল্লাহ হাফেজ।